Hello friends, welcome to this video lectures on experimental stress analysis. So today once again we'll discuss about the chapter number 6. So in the part 5 of this particular chapter we are going to discuss the initial balancing methods of the Wheatstone bridge circuit. Before that, in the last lectures of the same chapters we have discussed about the basic configurations of the Wheatstone bridge circuit. We have derived the derivations for the 8 configurations, that is for the single arm, 2 arm and the 4 arm sensitive bridge circuit. Then we have discussed about the transfer sensitivity or the cross sensitivity factor, which we have to introduce in the strain gauge applications. And now in this particular lecture we are going to discuss about the initial balancing of the Wheatstone bridge circuit. So related to this initial balancing, some of the things we have discussed in the introduction of the Wheatstone bridge circuit, why this initial balancing of the bridge circuit is required. As we know that in the Wheatstone bridge circuit it consists of a total 4 arms, and all the arms are resistant, all the arms are having the different resistance. That is the arm number 1 subjected to the resistance R1, the arm number 2 is subjected to the R2, arm number 3 is subjected to the R3, and arm number 4 is subjected to the R4. So the input is given across the terminal A and C, and the output is measured in the terminal B and D, that is E0, or this particular device is also called as a galvanometer, or this particular E0 is also called as a display unit. That means whatever the input is given to this particular bridge circuit, according to that input we have to measure the output across the terminal B and D. But if there is no any load is applied on that particular Wheatstone bridge circuit, or there is no any input supply, so this E0 should be is equal to 0, or there is no any reading which is in between across the terminal B and D. So for that purpose we have to balance that particular Wheatstone bridge circuit. Then what is meant by the initial balancing and how it is possible? Because as we know that in many of instruments you have observed that is, if any instrument will switch on, so if the instrument is started at that time without application of load, without any movement, the display of that particular instrument is also show some of the readings. But there is no any load, there is no any movement, then also the display will show the sum of the readings. Means we can say that your bridge circuit is not properly balanced. So for that purpose what we have to do, initially we have to balance that particular bridge circuit. That means we have to make that particular display is equal to 0. So for such types of the arrangements, in the display unit there are 2 knobs are provided, or 2 buttons are provided. One is the fine control arrangement and another is a coarse control arrangement. So what is meant by the coarse control arrangement? If display will show the maximum reading at that time, by using that particular coarse control arrangement I can make that is equal to 0. If instrument will showing some of the minimum reading, that is 0.01, 0.05 like that, so this negligible value also we have to make equal to 0, and it is possible by using the fine control arrangement. So such types of the fine control arrangement and the coarse control arrangement, such types of the knobs or the buttons are provided in the instruments to balance that particular circuit. But we are rotating that particular knobs maybe in clockwise direction or maybe in anti-clockwise direction. That means we are using that particular variable resistor, and by using that particular variable resistor we will make that display equal to 0, and once the display becomes equal to 0, then we are starting the readings by using that particular instrument. Now the same things we are going to discuss for the initial balancing of the Wheatstone bridge circuit. As we know that this Wheatstone bridge circuit is used for the strain gauge applications. So in this particular bridge circuit it consists of a 4 arms. That means the 4 strain gauges I can simultaneously mount on this particular bridge circuit. But if we have to balance that particular bridge circuit, all the strain gauges are having the same resistance value. For example, the arm number 1, on arm number 1 if the strain gauge 1 is there, arm number 2 strain gauge 2 is there, arm number 3 strain gauge 3 is there, and arm number 4 the strain gauge 4 is there. If all the strain gauges are having the same resistance value, for example 350 ohm, so all the strain gauges are having the same resistance value, that is 350 ohm, then this particular Wheatstone bridge circuit will show the 0 reading before application of load or before the application of movement. But in actual practice While manufacturing the such types of the strain gauges, it is not possible to manufacture the each strain gauge having the same resistance value. Some of the strain gauges are manufactured having the resistance of 349 ohm. Some of the strain gauges are manufactured having resistance 350 351 ohm. That means having same resistance value, such types of the strain gauges are not manufactured because there is some fault in the manufacturing process. If such types of the strain gauges having the different resistance values, if this different resistance strain gauges are mounted on the Wheatstone bridge circuit, at that time the bridge circuit is not properly balanced, means the display will show some of the readings before the application of load or before the any movement. But as we have to make that display is equal to 0, that means we have to balance that particular circuit, and that process is called as a initial balancing of the Wheatstone bridge circuit. And how this particular bridge circuit is properly balanced? So for that purpose, that Wheatstone bridge circuit should have satisfied this particular condition. So what this condition indicates, R1 upon R2 is equal to R3 upon R4. Means if you go through this particular figure, the R1 resistance is adjacent to R2 and this R3 resistance is adjacent to R4. Adjacent means they are near to each other, they are not in front of each other. So if you go through the figure once again, the R1 and R2 are near to each other, therefore these two resistors are adjacent to each other. Similarly, this R3 and R4 are also adjacent to each other, means they are near to each other. And as per the definition, as we know that is the ratio of resistance of two adjacent arms, that means R1 upon R2 is equal to ratio of resistance of remaining two adjacent arms. If this condition will satisfy properly, then and then only your bridge circuit is properly balanced. Means if all the resistors are having the same value, that is 350 ohm, therefore the 350 upon 350 it becomes 1 is equal to 350 upon 350. Once again it becomes 1, that means left side is equal to right side. Means if this particular condition is properly valid, or if this particular condition is properly balanced, then and then only your Wheatstone bridge circuit is properly balanced. And sometimes if any resistors are having the different value, or if any strain gauge is having the different value, that strain gauge resistance we have to change by using the variable resistance, and that particular process is called as a initial balancing of the Wheatstone bridge circuit. So this is about the basic definition of the bridge balancing, and for that particular bridge balancing, every Wheatstone bridge circuit should have to satisfy this particular condition. Now how this particular bridge is balanced, which types of the methods are used? So basically there are four methods are used for the bridge balancing. Out of these four methods, one is called as a series balancing, second one is called as a differential series balancing, third one is called as a parallel or shunt balancing, and the fourth one is called as a differential shunt balancing. So these are the four methods which are used for the initial balancing of the Wheatstone bridge circuit. Now one by one we'll start. So first is the series balancing. So if you go through this particular circuit diagram, again it consists of a one Wheatstone bridge circuit having the four fixed resistors, that is R1, R2, R3 and R4. So input is given across the terminal A and C. Output is measured across the terminal B and D by using this particular galvanometer, which is also called as a display unit. But sometimes all the resistors are not manufactured having the same resistance value. For example, this R1 is having the 350 resistance, R3 is also having the 350 ohm resistance, and this R4 is having the 350 resistance. But due to some manufacturing or faulty manufacturing process, this R2 resistor is manufactured having resistance is 348. So due to this particular 348 resistance value, your bridge is not properly balanced. So what we have to do, this R2 also I have to make from 348 to 350 ohm. So for this particular process, here this potentiometer is provided, and this particular potentiometer is also called as a variable resistance. So this particular variable resistance are connected in series with this R2. Why such types of the variable resistance are provided? Because by using this particular potentiometer or by using this particular variable resistance, we can make this R2 is equal to 350, because this R2 is one of the fixed resistor. By using that particular R2 only, it is not possible to balance the bridge circuit. But to change the resistance of this R2, the additional resistance is provided, which is called as a variable resistor, which is also called as a potentiometer. And by using this particular potentiometer, by rotating that particular resistance, or by using that particular variable resistance, I can make this particular R2 also is equal to 350 ohm. And if all the resistors are become the 350 ohm, then your bridge is properly balanced, means the display will show the zero reading. But this particular series balancing is having one major disadvantage, that is, in this particular arrangement, the fine control arrangement is not possible. Only coarse control arrangement is there, and in addition to that, the separate potentiometer is required to the each and every arm. Now in this particular condition, only R2 I have to change, but sometimes if R3 is having the resistance value 351 ohm, so I have to make it 350, means once again I have to provide additional potential to the R3 resistance. If all the resistors are having the different value, one is having the 350, another is having the 347, the third one is having the 352, and this R2 is having the 348, means all the resistors are having the different value. So if all the resistors I have to balance, then separate potentiometer is required to the each and every arm. Therefore, this is a major disadvantage of this particular series balancing. And in addition to that, the fine control arrangement is not possible. Only coarse control arrangement is possible by using the series balancing. And to avoid the disadvantage of this particular series balancing, the second technique is developed, which is called as a differential series balancing. So there is some basic difference between the series balancing and the differential series balancing. If you go through this particular second figure, again in that one potentiometer is also attached, which is called as a variable resistors. But here the potentiometer is connected in between arm R2 and the R4. That means this arm 2 and arm number 4 simultaneously I can balance by using the one potentiometer. That means R2 and R4 are simultaneously balanced. But once again, if I have to balance the R1 and R3 simultaneously, one more potentiometer is required in the differential series balancing. So means in the series balancing, 4 potentiometers are required, and in differential series balancing, 2 potentiometer is required. Also, the coarse control arrangement, fine control arrangement is not possible in the differential series balancing. That means in both the series balancing and the differential series balancing, the fine control arrangement is not possible, because this potentiometer or this particular variable resistors, by using this only the coarse control arrangement is possible. And to avoid the disadvantages of this series balancing and the differential series balancing, the third technique is developed, that is, which is called as a parallel balancing or the shunt balancing. Why it is called as a parallel balancing? Because whatever the variable resistance is provided, it is connected in parallel with the resistor which is mounted on the Wheatstone bridge circuit. So in the parallel or shunt balancing, potentiometer is not provided. Instead of that potentiometer, one shunt resistor is provided. But that particular shunt resistor is having one of the important properties, that is, this shunt resistor is having the maximum resistance value as compared to the resistor mounted on the arm of the Wheatstone bridge circuit. For example, if this R2 is having the 348 resistance value, then this shunt resistor is having the resistance value of 1000 ohm. That means this shunt resistor is having the maximum resistance value as compared to the resistor mounted on the Wheatstone bridge circuit. So this is the property of the shunt resistor. And one more, that is, the maximum change in resistance of the shunt resistor will causes the smallest change in resistor which is mounted on the bridge circuit. That means whatever the maximum value of the shunt resistor, if I will change the maximum value of the shunt resistor, according to that maximum value, only minimum value of the resistor will get changed, which is mounted on this particular Wheatstone bridge circuit. So means by using that particular shunt resistor, the fine control arrangement as well as coarse control arrangement is possible, which is not possible in the series balancing and the differential series balancing. Means by using the parallel or the shunt balancing, it is possible, that is find control arrangement as well as course control arrangement. But there is one more disadvantage is there for the parallel balancing. That is, once again, the separate shunt resistor is required to the each and every arm. For example, now here the shunt resistor is provided to the R2 because its resistance is 348. If this R3 is having the resistance value 352, and from 352 I have to become its 350, means one more shunt resistor I have to provide to the R3. If all the arms are having the different resistor value, at that time the 4 shunt resistors I have to provide to the each and every arm. That means number of shunt resistors are required in the parallel balancing. And to avoid this particular major disadvantages, the last technique is developed, which is called as a differential shunt balancing. So if you go through this particular construction of the differential shunt balancing, in that the potentiometer is also provided, which is connected in parallel. In addition to that, this shunt resistor is also provided, which is connected to the all the arms. That means by using this particular potentiometer, which is connected to the all arms, it is possible to obtain the course control arrangement. And as this particular shunt resistor is also provided, or it is also connected to the all the arms, means by using this particular shunt resistor, the fine control arrangement is also possible. And in addition to that, only one potentiometer is required as well as only one shunt resistor is required as compared to the remaining 3 techniques. Therefore, nowadays this particular differential shunt balancing is mostly used in various types of the instruments, through which the course control arrangement is possible as well as fine control arrangement is also possible. So this is the basic difference between the parallel balancing or shunt balancing and differential shunt balancing. So this is about the 4 methods which are used for the initial balancing of the Wheatstone bridge circuit. So once again I will take the overview, that is in the series balancing, as already I have explained. In the series balancing, the separate potentiometer is required to the each and every arm, and by using this series balancing, only course control arrangement possible, fine control arrangement is not possible. Then in the differential series balancing, instead of the 4 potentiometer, only 2 potentiometers are required, but the fine control arrangement is not possible by using the differential series balancing. Then in the third technique, that is parallel or the shunt balancing, in this particular third technique, the fine control arrangement is possible, but the 4 shunt resistors are required to the 4 arms. So to avoid this particular disadvantages, or to avoid the disadvantages of the technique number 1, 2 and 3, the last method is developed, that is differential shunt balancing. In this particular differential shunt balancing, only one shunt resistor is provided, which is connected to the all the 4 arms. Also only one potentiometer is provided, which is connected to the all the arms. And by using this particular differential shunt balancing, by using the potentiometer, the course control arrangement is possible. At the same time, by using this particular shunt resistor, the fine control arrangement is also possible. And whatever the disadvantages are there for the series balancing, differential series balancing and the shunt balancing, all these disadvantages are eliminated by using the differential shunt balancing. So this is about the 4 methods of the initial balancing of the bridge circuit. So this is about the initial balancing. So in this particular last video of this particular chapter, we have discussed about the what is meant by the initial balancing and how this initial balancing is possible in the Wheatstone bridge circuit. So we have discussed about this particular condition, how this condition should be satisfied, and then we have discussed about this particular 4 methods, and by using this particular 4 methods, the initial balancing of the bridge circuit is possible. So this is about the chapter number 6 of the part 5, and with this particular last part, we have finished this particular chapter number 6 related to the strain measurement, that is the electrical resistance strain gauge. Thank you.